Good day everyone, you're watching NeriChem. Phosphorus, group 15 element, the reason why you can light a match, and also of all the elements probably one which has the most allotropes of all. Let's get into it. So, phosphorus. Now, as we said, phosphorus is group 15, so this means it is in the same group as nitrogen and arsenic. So phosphorus is in period 3, so in period 2 we have nitrogen, then phosphorus period 3, and then we have arsenic, which is in period 4. Now these have 5 electrons in their outer shell and they are in the p block. So this is a p block element. The p block is on the right hand side of the periodic table, and p just represents the type of orbital in which these electrons, which are in the outer shell, are held. Now, I said in the introduction that phosphorus is one of the elements which has the most allotropes. I should probably first explain what an allotrope is. So, allotrope. I will write down the definition of allotrope, which would be an allotrope is an element which can exist in 2 or more, which would be two or more forms in the same state. This means that, for example, carbon has many allotropes. One would be graphite, one would be amorphous carbon. Well, phosphorus has also many allotropes. Black phosphorus, red phosphorus, white phosphorus. We also have diphosphorus, we also have ring-shaped phosphorus, then we have violet phosphorus, and we have phosphorus nanorods. So as you can see, phosphorus has many allotropes or different forms, and we will focus today on one particular example of phosphorus which is very close to home, which is matchsticks. So I will draw a matchstick. So here is my matchstick, and in red on the end I have a little solid blob, and I have a striking surface. Now, the matchstick itself contains potassium chlorate, which is KClO3, and the striking surface contains red phosphorus. Now these react together to give us the famous reaction. Now, just one note on red phosphorus. If I were to draw a sort of thermodynamics diagram where I have a vertical axis which represents energy increasing, if I draw here 2 lines, I would say that black phosphorus is lower down on the diagram and red phosphorus is higher up. So thermodynamically and kinetically, black phosphorus is more stable. So actually, kinetically speaking, black phosphorus is the most stable. Now, if we go back to our matchsticks, we see that this reaction will lead, of course, to the fire and the flame which we're used to seeing, but the actual chemical reaction which takes place is that this will turn into tetraphosphorus decaoxide and potassium chloride. To balance this, you need 10, 3 of those, 3 of those, and 10 of those. And these are all in the solid state. All in the solid state. Just to save myself the small S symbols, which are very tedious to write down. Now you might think to yourself, well, that's very nice that you've just given me that very lovely balanced reaction equation. Can you prove that it's balanced? Of course I will prove that it is balanced, which will actually help you in the future proving and balancing equations if I go through the mathematics. But just before I go through the mathematics, I should note that this is a named reaction. Named reactions are reactions which are sufficiently famous to receive the name, usually from their inventor. So just as a side note, this is Armstrong's mixture, which in sufficient quantities would give a very explosive reaction, just like taking lots of matches and striking them all at the same time. Now, William Armstrong was a 19th century inventor and scientist. So let's go through the balancing mathematics. So here we see that we have chlorine, which is with 3 oxygens. So oxygen always carries a -2 charge formally because it is the most electronegative atom in this entire molecule. So that would be -2 times 3, which would be -6. And potassium has a single positive charge, so the chlorate anion has to have a single negative charge, which means that chlorine is in the +5 state. Now P4, which is just red phosphorus, we know has a formal charge of 0 because it is an element. Elements take a formal charge of 0. Now oxygen, so that's -2 times 10 is -20, which means that we have 4 lots of a certain amount of charge needs to equal +20. So we know that 4 times 5 is 20. So this is +5. And we know that, again, potassium is +1, so chlorine has to be -1. So if we take phosphorus, we see that a single atom of phosphorus goes from 0 to 5. So 0 minus 5 equals -5, which is equivalent to a 5 electron loss. And we see that for chlorine, we go from the +5 state to the -1 state. So that is 5 minus -1 equals +6, which is equivalent to a 6 electron gain. Now, let's check the mathematics. We see that these equations, which are here below, represent single atoms, which is why there is only one P and one Cl on the left-hand side of the reaction logic. So we see that there are 4 phosphorus atoms in a single molecule of red phosphorus. Of course, red phosphorus is an entire lattice of phosphoruses, but there are 4 per empirical unit. and we see that there are 3 in the balancing, which you just have to trust me on until I prove it to you. So it would be 3 times 4 times 5 electrons lost. 3 times 4 times 5 electrons gives us 20 times 3, which is a 60 electron gain. And this is of course for phosphorus. Now for chlorine, you can do the same thing. We see we have 10 chlorine atoms, which are all gaining 6 electrons, and of course there is only 1 chlorine atom per potassium chlorate molecules. So this would be chlorine, which is 6 times 10, which equals, and this is of course a loss, excuse me, this is a 60 electron gain. So we have proven that P minus Cl equals 60 minus 60, which equals 0 electrons net. Therefore, equation is balanced. Perfect. So now we have proven that this equation is indeed balanced. Now, the Armstrong mixture you will see on screen now, and it is very explosive. Phosphorus, of course, is an element which should be taken seriously, because it is a dangerous element to handle. White phosphorus was banned because it is dangerous to inhale, for example. So I hope this was useful. I hope you've learned about phosphorus, and I will see you in the next one. Goodbye.